Hello there. Time to continue our lesson in section 9.1 about antiderivatives and indefinite integrals. And we're learning goal number 2 this time, where we're going to talk about properties that you can use for finding indefinite integrals. Now, so far we've said only one thing about an integral, and that's that an antiderivative and an indefinite integral are the same thing. Alright, so in this lesson we're going to be using the terminology indefinite integrals more than we'll be saying antiderivative, but the same process. And let's get right into it. When we're talking about indefinite integrals, okay, that again is just another name for anti-differentiation, which is something that you ought to know. And another thing that you ought to know is that there's some nice, good notation that goes along with finding an indefinite integral. Okay, so let's look at the notation for indefinite integration. Now, you guys are used to the notation for derivatives where you'll put f prime of x or f double prime of x for a second derivative. When you want to indicate that you're about to take the integral of a function, use this nice little S shape right there. Alright? And so that means the integral of function f, and then this dx part means here, or right here, tells you what variable you're integrating with respect to. This is the integral of function f with respect to x, as you see right there. So, for example, if you see this right here, this means to find the integral of the function x to the 6th power with respect to x. This means find the integral, the indefinite integral in particular, of 1 over x cubed with respect to x. And by the way, we've really learned how to do those things, we just haven't used this notation yet. When we are learning how to find the antiderivative of a power function, well, we said that if you have the function x to the nth power, the antiderivative, or the indefinite integral, can be found by increasing the exponent by 1 and then multiplying the whole term by the by the reciprocal of that exponent, and then adding a constant term. And we also said n cannot equal 1 because, well, n cannot equal -1. That's a misprint from that textbook right there. Hold on a second. There, that's better. We also said that n cannot equal -1 because then you'd be dividing by 0 whenever you multiply by the reciprocal of your exponent. Alright, and then if you follow that power rule for this function right here, increase the 6 to a 7, multiply by 1/7, you get that the integral of x to the 6th power with respect to x is 1/7 x to the 7th. And if you think of this as x to the negative 2nd power, x to the negative 3rd power, well, increase the exponent to -2 and multiply by the reciprocal of that, you're going to get that the derivative of 1 over x cubed with respect to x is -1/2 x to the negative 2nd power. Alright, hopefully that whole idea of anti-differentiating a power function is still fresh to you. Now, that's one of the rules for finding indefinite integrals that I wanted to talk about in this video, but it is something we've already talked about, the power rule. Let's go on and talk about some other rules. And there are 3 other rules in particular that we're going to learn. 3 very basic things that apply to integration at all times, it turns out. Not just to power functions, but to any types of functions that you can integrate. And the first of those rules is called the constant rule. And that simply tells you what you do if you want to find the integral of a constant. Such as, let's say I wanted to find the integral of 5/9 with respect to x. Alright, so this is just a constant function. We're pretending, well, not really pretending. We're saying that we have some function f of x that's just equal to 5/9. Alright, and we're going to try to find out essentially what would you differentiate that would give you 5/9. Well, remember, if you take a derivative of something and it leaves you with a constant, that's because you just had an x to the 1st power right after it, right? So the the integral of 5/9 with respect to x, I don't know why that went to the next slide altogether. No, because I don't have that written on there. The integral of 5/9 with respect to x is going to be equal to 5/9 x, right? The derivative of 5/9 x will give you back what you started, plus c. And that's all that this constant rule is saying, is that whenever you try to find the integral of some constant k, you're going to get k times x to the first power, plus a constant. So, then the derivative, not the derivative, the indefinite integral of pi with respect to x would simply be pi times x to the first power, plus a constant c. Alright, it doesn't get a lot easier than that. Alright, let's move on. Here's another rule that has the word constant in it, but it's not the same as the constant rule. The constant rule is for integrating a constant. The next rule we're going to look at is called the constant multiple rule. And the constant multiple rule is when you're integrating a function f of x, but you're integrating a multiple of it. You can see here how I have an f of x, but it's being multiplied by k. And it turns out whenever you're integrating a multiple of a function, what you can do is you can just find the integral of that function and then multiply that result by the constant that you had. Alright, so, for example, here we have two functions in which we're multiplying, or two integrals in which we have some function x to the fifth here being multiplied by a constant -3. Here we have the function 5 over 2 times the square root of x cubed. Well, 1 over square root of x cubed is what you could say, and it's being multiplied by 5/2. And in order to find the indefinite integrals of each of those things, here's what we're going to do. We're simply going to say that that's the same thing as if you pulled the constant out front and you made this -3 times the integral of x to the fifth dx. Alright, now the integral of x to the fifth would of course be 1/6 x to the sixth. And we'll put our constant term at the end. And then we can just simplify this. We can multiply 1/6 x to the sixth by -3 and get -1/2 x to the sixth plus c for our integral. And you can always check these things with differentiation to make sure that you did it right. Alright, the derivative of x to the sixth is 6x to the fifth. If you multiply 6 times -1/2, you get -3. Like we started with, and then that exponent becomes a 5. Check, we got that right. Go ahead and integrate the second thing for me. Alright, you can take a look at what I did, and I just wrote this first step because I wanted to make it a little more clear. If you just had 1 over the square root of x cubed, you would have x to the -3/2 power. But since we had the 5 and the 2 there, we had like 5/2 times x to the -3/2 power. Alright, so then I pulled the 5/2 out front, integrated x to the -3/2 power, increased this by 1, get -1/2. The reciprocal of that is -2. And then in the end, I just had to multiply the 5/2 and the -2 basically, which gives me -5 x to the -1/2 power plus some random constant. That's our indefinite integral. Good. We've got one more rule to look for here. And that rule is called the sum or difference rule. Alright, now this looks pretty complicated, but all it's talking about is if you have some integral where there's multiple terms within the integral that you're going to have to integrate. Alright, if you have the integral of some function f of x plus some function g of x, you can just separate that into two separate integrals. You can integrate the first function and then add the integral of the second function. Okay, or if it's subtraction, then you take the integral of the first function and then subtract the integral of the second function. Alright, let's look at that. Here are two examples to apply that to. All right, with part A, the f of x and the g of x that we're talking about are simply the two different terms here. I didn't mean to write on that. The two different terms. Here's function f, here is function g. And we're simply going to divide out those terms. We're going to make this the integral. And I'm going to go ahead and write that in exponential form. Of x to the 3/4 power dx with respect to x minus the integral of 6x with respect to x. And now we can just go ahead and integrate each of those terms separately, and it's going to work nice and easy for us. All right, x to the 3/4 would become, well, x to the 7/4 power with a 4/7 in front of it then. We only have to add a constant term at the end, and we don't have to add it after every term. Now this 6x would end up being 6, pretend I pulled that 6 out front, 6 times 1/2 x squared plus c. So 4/7 x to the 7/4 power minus 3x squared plus a constant. All right, apply that sum or difference rule to part B for me, please, and then check your answer momentarily. Okay, let's go through the work for that. You can see that I separated the integral of that 3-term expression into 3 separate integrals. Okay, now what I didn't do, but what I could have done, is I could have pulled each of the constants in front of the integrals. When I do the integrations, I'm going to think about that 8 being in front of the integral. I'm going to think about that 12 being in front of the integral. This 5 being in front of the integral. All right, well, I might not think about that with that 5, but I'll get there momentarily. Okay, so we're going to get then, for the first term, 12 times the integral of x to the 5th, which we know is going to be 1/6 x to the 6th, minus 8 times the integral of x to the 4th, which is going to be 1/5 x to the 5th, plus, and remember when you integrate a constant, you just put an x at the end. So the integral of 5 with respect to x is just 5x. So that turned out to be super easy. I just wrote it that way. And then that gives you 2x to the 6th power minus 8/5 x to the 5th power plus 5x. And then I forgot to write plus c on the previous step, but I won't forget it here. You always want to remember that constant term at the end of your indefinite integrals. All right, that's how you use those very basic rules for finding indefinite integrals. Hopefully you find that fairly simple. We're going to work on this obviously more within class. So thanks again for listening. I'll see you in class.